Okay, these are the 5-7 notes, which is the second derivative test, which we can use the second derivative to determine a max or min of a function as well. I recommend never using this unless you have another choice, because this can confuse people sometimes. And sometimes on the AP test, they will only give you information about the second derivative and enough information where you can only use this to tell if there's a max or a min. So you need to finish this worksheet and get it turned in by Monday. And remember, you're going to put this on Canvas. And then next week, we're going to have a quiz on 5, 6, 5, 7, which is the last quiz in this section. So the second derivative test says this: if f is a function where f prime is equal to 0, which means f prime equals to 0 is what we learned our critical numbers. Okay, and if we plug in those critical numbers, we find C to find those critical numbers, and if we plug those into the second derivative, if the second derivative at that critical number is greater than 0, what that means is concave up at this critical value of C. Since it's concave up at the critical value, it has to be a minimum. Since the second derivative is positive, that means concave up. If the second derivative is less than 0, meaning the second derivative is negative, that means the graph is concave down at that critical number, which will make that critical number a maximum at this C value. So what we're going to do is find the critical numbers first. Now, in the AP test, a lot of times they give them to us. So to find the critical numbers, we use f prime of x. And I cannot see that. So I'm hoping I have that problem. I can't see the exponents very well, so I got to find that real quick. Okay, so it says negative 3x to the fifth. So the first derivative is negative 15x to the fourth. And 5x cubed would be plus 15x to the second. So to get the critical numbers, we're going to set this equal to, 0. Find critical numbers. And I probably should have put f prime equals 0, just like we always do. And the other critical numbers could occur where f prime is undefined, but there's no variable here, so we don't worry about that. I'm going to factor out a negative 15x squared from both of these, which is going to leave me at positive x squared there and a negative 1 here. And then I set both these equal to 0, so I get x equals 0. Here I get x squared minus 1 equals 0, and I add the 1 over and I square root, and I get positive negative 1. So here are my critical numbers. These are the possible places where I have max and mins. So what I'm going to do is do the second derivative of this function up here. So I'm going to get 4 times negative 15 is negative 60x cubed. And then I'm going to do plus 2 times 15 is 30, subtract 1 and get 30x. So I'm going to find what the value is at negative 1. So if I plug negative 1 in here and cube it, negative 1 cubed is negative 1 times negative 60 is 60. And negative 1 times 30 is negative 30, and I get a positive 30. What that tells me is this graph is concave up, because this is greater than 0. Greater than 0 means concave up. So that means at negative 1, I have a graph going like this. So that means I have a minimum. I have a minimum at x equals negative 1. Now, I didn't find the value that the minimum equals. Let's see. All right, it does say the find the extrema, so I need to plug negative 1 into the original function. So I'm going to also plug f into negative 1 into the original function to find the y value that goes with that. So I'm going to take negative 1 to the 5th power is negative 1 times negative 3 is 3. And negative 1 to the 3rd power is negative 1 times 5 is minus 5, so that's negative 2. So I can say f has a min equal to, get this out of the way, negative 2 at x equals negative 3. Now, if it wanted me to name the point, I would say that you would have a min at the -1, -2, but I want you writing it like this. And if it asks why, we would say because f prime of -1 equals 0 and f double prime of -1 is greater than 0. That is the reasoning. Now we do this again. We're going to do f double prime of our next one is 0, so I'm going to plug 0 in. So when I plug 0 into f double prime right here, I get 0 and 0, which is 0. And then I'm going to, so what that means is, I got 0 for f double prime. That means there's no concavity there. So what that is telling me is that I don't have a maximum or a minimum there. So, all right, I don't know. We can't tell because we don't know the concavity. So we could put inconclusive. Or we could say don't know, can't tell. So we don't even need the y value. And then the last, we need f prime of 1 because that's our other critical number. And f double prime of 1 is going to give me -60 plus 30, which is -30. This tells me that we're concave down, which tells me it's going like this. So I'm going to find that y value that goes with that by plugging 1 back up here to the original, which is going to be -3 plus 5, which is 2. So I can say f has a max, or relative max, equal to 2 at x equals 1 by second derivative test. So that's what we're doing on these problems. So we're going to go on here and do the next problem. This is the last problem, by the way. Now we're given a value of charts, okay? So this says, given the value below for x, and this is more like what they would show you on the AP test, by the way. Given the values below for the x's, which are across the top, these are the x values, the f of x values, which are, there's the ordered pair that goes with them, there's the x, y. The first derivative values are here, and then the second derivative values here for the same function. And it says the fact f prime has only 2 zeros on the interval from -3 to 10. If you look, 0, 0. There's an undefined here. Means that that could be a critical number, but we're only going to check double prime for those. There's only 2 intervals. So identify all x values where f has a relative min. Okay, so this says justify using the first derivative test. Hold on, my phone's ringing. Gary, I'm doing a video. Okay, so we're going to do this with the second derivative. So I got a 0 here, right? That's a 0. So that means I want to look at the concavity here. So since f double prime is -1, that means that we have a relative min, because concave down is what second derivative means here, with that being a critical number. And it says only the x value, so x equals -1 is going to be a place where there's a relative min. If we wanted a y value, it would be that 1. And that, we'll see, here's a positive number, so this would be a max because this is concave up. The critical number happens at 3. Concave up means that there's a -4 would be a relative. Oops, I got that backwards. This is a relative max. This is the min. So I should have said at 3. And then down here, this would be x equals -1. I said verify this using the first derivative test. Well, we know this is a critical number. And what does this say about the slope to the left? That is a positive slope, because positive, and the slope to the right, that is negative. So the slope changes. F prime changes sign from positive to negative at x equals -1. Oops. I should have put that down here. My bad. Let's change this. Again, I did the max. F prime changes sign from positive to negative at x equals -1. Up here, f of x changes sign from negative to positive, because on this side we got a negative, that side a positive, and then we would say at x equals 3. So you can see it works both ways in the chart. It says identify all x values that has a point of inflection. Well, if you remember, points of inflection occur when the second derivative changes sign and where it is 0. So for this part, I am looking for zeros of the second derivative. So this and this are 0 values for the second derivative. So I want to look on each side and look at my concavity. So we're negative on this side, positive on this side. That means concavity has changed at x equals 1. So, and this only says x value, so we know there's a poi at x equals, that's where the 0 is, so it'd be that 1. And let's check here, that's positive, positive. There's no change in sign there. So because there's no change in sign, we don't think that's there. So we would just say there, and it's because f double prime changes sign at x equals 1. And we got one more problem and I'm done. What is the equation of the tangent line for the curve here at x equals 5? So tangent line, I need a point and I need a slope. Well, at x equals 5, I got to go find a y value that goes with 5. So here's the x value of 5, there's the y value. So my point is 5, 3. The first derivative, which is this line of 5, is 2. So that is my slope from the chart. So what I get to do is plug that into my point slope formula. So I get y minus 3 equals 2 times x minus 5, and there is my tangent line. And that's the end of this. Have a great day, and I will see you tomorrow.